filter. So I think it's recording now. So okay, we have a little bit fewer people than usual. I'm not sure. Is some of you not sure we have class or not. So I guess this online thing is great except for the snow day. So let's see. We'll continue with filter and then do some example against on OpenCV. So last time we ended here. So I guess for I don't know why my computer appeared quite slow. So hopefully nothing's going wrong and then get stuck. So maybe I really should take a look. It's fine. So okay. So I guess I will give an example like in 1D first. Um so we have I guess what I want to say is that maybe some of you uh last time I guess we ended have that filters is like this one. So and then some of you have questions like why have like low pass in one way and then like high pass on the other way. Or like maybe depends from where you from. I don't know because my original background is triple E or like double E, electrical engineering. So I'm quite like familiar with the language, right? Low pass and high pass. Maybe if you're from CS, I don't know what's the language there, but because electrical engineer like used to work a lot on signals, so we talk about like DC and AC. I guess dates back like for the was that data back for the heavy was that called uh electrical like that kind of like what kind of motor you have like DC current, AC current, and so on and so forth. Um, and so, and if you look at like, let's say if I have a signal like this, so this is my signal just oscillating. So it's a discrete. So I didn't draw it really well. So it's a oscillating with 4 and 6 way. The first uh, for the first discrete. First one is four, and then the next one is six, and so on, oscillating like this. So I can decompose this signal into a DC and AC component. So it's just a uh, so what's DC and AC stand for? Like alternating current or like whatever. So basically, think of like okay, I have this signal here, but I can like think of it as actually a constant signal. Just like at five added like oscillating like from -1 to 1 and so on. And for this one, like you see the average or the mean of this signal is just 0, right? So the point is like for this AC part, um, the alternating part, like I'm just having this is like the average is 0, and the constant part is just a constant basically. Now, if I think of like I'm going to apply a filter or like yeah, you can think of filter is basically um, have a dot product of this guy, have this thing like moving along here. So, and I would just say have this basically this shifter like first like here, put it here is a -1, 1/2 of them, right? And then like I'm going to compute the values would be like this value multiplied by this. I mean this value will be 4, like 4 multiplied by -1 per se 6 multiplied by 1. Or because like this signal itself is like decomposed into like this DC and AC component, right? I can think of like what's the first of all, because like this thing is a linear operation, this filter linear operation. We will get more detail later on. But you see that like applying this thing here or like this S here, let me just say this is S here. And I have this as applying on this DC plus this AC component, that's original signal here, this signal here, decompose into DC and AC, is the same as I apply on DC and apply on AC like that. So when we have a system like that, like this S here, like this, we call this is linear. You may came across that like before, like maybe in some cell processing class or like something like if you're coming back from like electrical engineering. But if no, it doesn't matter. It's a very simple concept. It's just say if you have this system applied to a signal, the signal decomposes into like two parts, and if like is equal to that signal applied to each of the part and added them together, this is linear. So this operation is that you can easily verify is linear. So then if I apply this like to the DC part, you see like it would be just equal to zero, yeah? Because every time you just this is a minus 5 plus 5 over 2, right? So you always get 0, 0, 0 all the way. And for the AC part, you will just get back an oscillating signal. So therefore, like people will say this is like a high pass, or like signal processing people like to call this a high pass filter, because essentially like the component that's oscillating, you can think of it as a high frequency, because it's you can think of this like the speed of oscillating is the frequency, right? So apparently, if it's not oscillating, then there's no frequency there, or like you can think of the frequency or the wavelength. I don't think of wavelength, make it complicated, but the frequency is like was how many times you oscillate per second, right? Or like per in this time say per step, right? So in this case, the for DC this every level oscillate, therefore the number of times to oscillate per step will be like basically zero, right? But in this case, you have like a much higher value. So therefore, like for the AC, it's really like a high frequency component. This is a low frequency component. So as you can see, that low frequency component just do not get past that. Originally, you have like some constant value 5 here. After you go through this system, you just have nothing. So therefore, like it just it didn't get past that. Only the high frequency component get past that. So therefore, it's a high pass filter. So is that clear about this? So on the other hand, I can have a low pass. It will be instead of minus 1, 1, I can have 1 and 1. So like this one here, I may have a low pass filter. In this case, now it's low pass. So it's exactly the same case. I just have the same signal. I split into like DC and AC. But if I think of them, what is passing through here, I have now the DC component get past that way. Original the constant is constant value 5. After this filter, I still have constant value 5 here. On the other hand, the high pass component now, if I just apply this filter is here, is a will be again we are doing dot product, right? Just make sure you understand what we're doing. We're just doing taking this filter and like put it here and dot product with this signal here, right? So basically we'll just get 0 every time again. So because I get 0 every time, so therefore like this doesn't get past that. So it's like the high frequency component doesn't get past that. Like this is like just say like this doesn't get past that, but the low frequency component get past that. Therefore, like this is a low pass filter. So now if I get back to here, like the last time we ended here with that Einstein image and let's see if I can get a pointer with a pen here, even though I don't like to draw on PowerPoint because it doesn't have a, oh, okay, it already disappeared. This is so, yeah, it's here again. It's not here. I don't know, this is so weird. Oops, that's, forget about it. Um, Okay, I cannot erase that. I don't know for any reason. So so anyway, like we have a filter like this. Well, let's think of like what is this one? I can decompose this as this guy, right? 1, 2, 1 multiplied by 1, 0, 1. 1, 0 minus 1. I mean decompose is like you can think of like, okay, I will just go back to here to draw like it will be easier. So I mean I have something like 1, 2, 1, 0, 0, 0, 1, minus 1, minus 2, minus 1. That's the filter. So you can, let me call me this filter F like something. So I have F ij component is basically this guy. So my index can be like, let's say if it's minus 1, 0, 1. So for kind of like just I want to make the center here 0, 0. So therefore I have index minus 1, 0, 1, and this is minus 1, 0, 1, let's say. And maybe this is the I component, this is the J component here. So therefore I have like, let's say F, okay, let's just check like you do what you're following what I'm doing. So what is F1 minus 1? So question here, like really simple question, was F1 minus 1? Okay, okay. Be very careful, like the index I'm showing, right? Are you sure? Like F1 minus 1. So the index is like I index is like here, the J index is here. This is a I. Yeah. So this is the I index, that's the J index, right? So I is 1 and J is minus 1. I have like, yeah, minus 1, right? So now I notes that I can decompose this Fij, decompose in the sense that Fij is equal to, let's say I call it F1i multiplied by F2j, where F1i was for F1i. F1i is where F1 is a 1, 0, minus 1, and F2 is 1, 2, 1, or like maybe I write it vertically, you can see more easily, right? So you agree with that? Like basically, I have you can basically easily verify that, right? For example, like I have this F1 minus 1 is F1 I, basically it's like this guy, right? F1 I is this one. Let's just take a couple examples, just make sure. So I have F1 minus 1 that I say is equal to this guy here. Oops, let me draw here better. So it's equal to minus 1. And F1 1 is this guy here. Okay, it's minus 1. And F2 minus 1. Minus 1 is this guy here, is 1. So indeed, like I multiply this is equal to this way. So maybe just do one more. So I have, let's say, take which one is better? Maybe take this one. So this one is a F minus 1 and 0, right? This one is I expect to be 2 F1 minus 1. I say it should be equal to F1 minus 1 multiplied by F2 0, right? So F1 minus 1 is 1, right? And F2 0 is 2. So indeed is true, right? So now think of what we are doing filtering here is like, let's say filtering is basically like in 2D, like we show a 1D example of it, but in 2D is like I have this patch I'm doing in the product with like a particular patch of image, right? Basically have this, let's say this is an image here. So I will just have like this move around and do a dot product, like with like, let's say if I want to find the filter result of this particular pixel here, this would be like I taking the label way, like the entire patch here, do a dot product with this guy, right? So then that would be equal to, therefore that would be equal to, let's say the image I call it I, let's say at the XY, let's say maybe I write like the I filter image, the filter image at XY location will be just equal to Fij, yeah, Fij is okay. Fij, I, this is the input image, I plus X, or like, let me write X plus I, X plus I, oops, I guess I better maybe like make this image a cap I here. So image cap I, and then Y plus J.
Dr. Chang, can I have a
Yes,
question?
yes.
So in this equation, x, y, so that is the x is the row and y is the column of the pixel. Is it right?
Yes, yes. X is will be the row. Will be the row here. X will be the row. And if I follow the same index here, yeah, X will be the will be this direction basically, and Y will be this direction.
But in
Yeah,
the
yes,
but in the function f, the
yes.
ij is opposite direction, right? I is the horizontal.
I am still drawing the same direction. I think like I am drawing this direction as I here. J is this
Oh, I
direction.
see. Then in the equation, x represent the column of the pixel, right?
Oh
We
yeah,
can
yeah.
think
Okay,
about it as a matrix.
that would be a transpose for the matrix. But here, don't worry too much about that. Like this, I probably have a. If you want to put a matrix, like for the matrix convention, like this will be the first index, right? Yeah, I see what
Right,
you're going, right? But
right.
this is the second index. But yeah, I just arbitrary. I mean, like, I pick this direction now because it's more
The
you
natural,
yeah
like x
yeah
and
more
y.
natural like that. It
I
will be
see.
the first index. But yeah, if you put it back into matrix, will be a transpose. Yes.
Oh, okay, I see.
Yes.
Okay. Yeah,
Yeah.
great.
So, okay, let's continue with this one here. So actually the filter is doing is a, this maybe sum over, put two summation here. I equal to -1 to 1, and J is equal to -1 to 1. Right, that's exactly what we're doing, right? So the XY, when you do the filter image, the XY pixel here of that filter image will be, I take the patch, right? X, this is essentially get the patch, right? So I from X here, I move like a pixel before that and pixel after that, um, and pixel above that and below that, like with that index like -1 to 1, and I is -1 to 1, and J -1 to 1, right? So, and then because I have this F can be decomposed, right? So I can have F1 I, F2J, right? So then I can move the summation now around, right? So I can, okay, maybe I just do one more, don't erase that. F2J, then this summation is only depend on I, right? So therefore like my F, this F2J only depends on J, right? So I can move outside of the summation. So therefore I have J equal to -1 to 1, F2J, I equal to -1 to 1, F1I, Ix plus I, Y plus J. Okay. So now what you can see is like here actually is decomposing to two 1D filter. And this one is doing a filter in the horizontal direction. Okay, so let's say go back to this patch. I'm zooming this patch here, like have like this one here, the entire patch like that. Now it's basically I doing this kind of, let's say like dot product of this filter, like Fij here is the same as I first do a 1D dot product along, let's say, the horizontal direction. So here I have, let me give some precise values. Let's say I have the, okay, let me actually make something like that, right? 1, 1, 2, 2, 2, 2, 2, 2, 2. So what is this? So okay, okay, maybe I can make a question here. So I would say this is an edge. So is that a vertical edge or a horizontal edge? Horizontal. So most of you get this right. So this is vertical. You must you just kind of like visualize this this as an image. So if you think of this as an image, let's say if I have this instead of 1, maybe I make it even 0, a little bit larger contrast. Maybe like this is a even bigger value. So then what you see will be something like, maybe I make it bigger, maybe 200 instead of 2. Let's say. So this is a 200. So then like you will have like something dark here, right? And then this 4 pixels is rather bright. So then actually sorry, it's not 4. Like this 6 pixel will be rather bright, right? And then like this 3 pixels will be pretty dark. So this apparently this is an edge, right? This is a vertical edge. Now if I apply my filter to this guy here, so I can first apply, okay, as I said earlier, I apply that filter will be the same as applying first. Of course, I can do the other way one, vertically, horizontally. But if I, okay, maybe I just emphasize that. Like this is not the only. Okay, yeah, this is not the only way, because I can also like move this summation, J summation inside first, and then I do the I summation. So that is actually the same as I move J inside first, then do the summation on I. But of course, if I move the J inside, I will pull out the F1I outside instead, right? So, but that is, so you can do like horizontally first and then vertically. It doesn't matter. The order actually doesn't matter. But okay, let's forget about it. It doesn't matter. I just want to put a remark here that the order of like doing that doesn't actually matter. But let's go back to here. If I do this order first, so I have like first computer along the horizontal direction. As I said, like that patch here, maybe I put it back here. It's 1, 2, 1, 0, 0, 0, minus 1, minus 2, minus 1 is equal to like 1, 2, 1, and like my actually the yeah, it's okay, 1, 0, minus 1. Then I do the let's see, do the horizontal one would be like trying to apply to this filter, right? And I'm going to apply this. I know that like for different J, So okay. So I guess I say also like put the remark there like here is you I that's actually the same problem like the convention problem because when we have for the matrix like the convention is like the first index is actually uh if you think of this as a matrix, the first index is this direction, right? The second index is this direction. But here, like the um basically the index like with the yes 200 is a pretty bright. Yeah, 200 would be pretty bright. So typically if we play with like for example OpenCV like RGB like each of them if we the will be like 8-bit uh the intensity resolution. So therefore, the maximum will be 255. So if I get 200, it's pretty bright. So if you just look at, uh, yeah, look at this, that would be the edge, right? So you have, yeah. So, okay. But for the matrix thing, it's unfortunate. This is because you have the image, you you kind of like tends to have like this is the first essay, right? This is X, this is Y, right? But on the other hand, like um frequently like usually we will consider this will be the first index, this is the second index, but in terms of like playing with matrix it will be exactly flip. So yeah, this problem is not exactly a problem, like this is unfortunate convention. This sometimes you encounter for some MATLAB, OpenCV and so on. Just when the image is flipped, then like you need to do some transpose like to that image. So okay, but here I just want to visualize better. So therefore, like I just think of okay, this is the first index. This is the second index, and yeah. So okay. Anyway, so yes, we are going to do the filter on that. So, but just I start with okay, we have this image. You want to see like, if I apply the filter on this image, then what will happen, right? So I apply this filter now. Of course, I can just compare this directly to this guy here, right? But or I can like, apply this um like decompose into the first like in the horizontal and then the vertical direction. So as you can see, like this, what we are doing is actually doing a for uh for this part here, we're actually taking each of the rows here, and then do a dot product with this one, right? So if I take a dot product of this guy here, then what we will get will be what? Will be okay, will be some values actually will be just basically equal to like 200, right? So that is actually just equal to 200. Actually minus 200, right? And also like the second one here, apply to the same filter apply to the second row here, I will also get minus 200, and then apply to the third row, it will be minus 200 again. So now then after I finish this guy, I have this kind of vector here, and I apply the vertical in the vertical direction here. Again, I basically be like having dot product of this one, the output of this from this one with this guy here, then I will get like uh this is equal to what 600, I think, like something like yeah, something like maybe even more larger than that, maybe 800 minus 800. But the point is here is like I will have some value is non-zero, and I And this is exactly like what we have here is like we actually detect a vertical edge here. When we have a vertical edge and apply on this filter, you can see like along this horizontal direction, because it's a vertical edge, along the horizontal direction is actually it's like a high pass signal. So therefore, like that signal is like going to be will not be filtered horizontally by this high pass filter, because like the horizontal direction is actually a high pass filter. And along for the vertical edge, along the vertical direction is a low pass signal. Again, this um will not be like filtered by the low pass along this vertical direction. Therefore, like I will get this signal passing through. Therefore, like I can detect the edge. So I mean detect in the sense that like when I have this vertical edge, oops, I cannot find my, okay, here. When I have this vertical edge here, and I apply this filter on this vertical edge, I don't have the, I will get a non-zero value. So, okay, I think that this is good to give another example, just let you guys to see it yourself. Maybe like, okay, let me try another question. Like just,
Dr.
okay,
Chen, I have a question.
yes,
Can I ask a question?
yes.
So I think the pixel values can be from 0 to 256. So then
Oh
what
yeah,
does it mean, the
yes, but the filter
minus?
value say, okay, this is the thing. Like after you do the filter,
Mhm.
You get bigger than whatever. Like then like that okay. That's typically like when you before you apply the filter, you may want to convert to the full float. In some case, it depends. Like or like then like you can have like resolution. I mean, like you can have like values like get beyond like 250, 255 and so on. Then you can get it back like yeah, after like um, get back to the lower position,
I see.
back to integer. But of course, you probably want to scale it. So I here like for one thing is I make it a little bit simpler. So typically you want to normalize the filters here. So therefore, like I'm doing this without normalization, but actually, um, the filter that really I should use should be like this. I should put a 1/2 in this direction. Then I can make sure that it will get back like the energy is 1/2, and this one I probably put 1/4 here. So therefore, like I should have like this filter like over by 1/8, something like. But here I omit this scaling just to make things kind of a little bit simpler. Um, so any other questions? So okay, let's just make sure that like you guys are following. So uh let me consider another signal here. Let's say I have yeah, I have some signal like so just a okay, just everything is flat. So I have 100 everywhere. So if I apply filter on this, so what's the value for that guy? For this guy, what's the I'm what's the filter value, filter output? So, oh, okay. Anyone, this is supposed to be a question actually. So what was the filter output? Yeah, yes. Actually, very simple, right? So you can directly like do a dot product here, right? Dot product of this guy to get like 0. But I also want you guys to visualize that this is 0 because when I have this filter, it's actually doing a low pass on this direction and high pass on this direction. I mean, if you think of this signal here, I have low pass on this side. Oh, sorry, not low pass. I have like low frequency on this side, right? Low frequency component only on this side. I'm also like low frequency component on this side as well. So therefore, like, okay, I can get it full like in this direction, but I cannot get it full on this direction because I have high pass on this side. So if here along the horizontal direction only have like low pass, so low frequency component, it just cannot pass through the filter. So therefore, I will get 0. Now get one final example. Like, so just make sure you
Dr.
guys
Cheng,
are
I
following.
have a question.
Yes.
So what about the first columns?
The first column.
So for example, let's say in the first column of this the 100 pixel, the picture.
Yes.
What about in the middle one? The first,
this one?
The middle one in the first.
This one?
Yes.
Oh, that we got like minus 800, right? So okay, yes.
So that is
let me
minus
put it this way.
100,
Okay.
right?
Yeah. This okay. Anything non-zero is like getting passed through that would be like have a signal. So if I look at like this guy again, like what was this one? Actually, I have some high frequency component on this direction, and I have some low frequency direction in this direction. Right? Everything along this direction is low frequency. They have like same values. And this is a everything along this direction is a high frequency, right? No, there's some high frequency and some low frequency. I can argue about that. Like this is like a little bit low frequency, right? If you think of like all high frequency will be like oscillating like 0 to 100, and this is like 0 or zeros again. But at least I have some high frequency and some low frequency, right? And for this filter here, I basically I will let low frequency pass vertically, right? I allow low frequency pass vertically. This I allow only high frequency pass along this direction. So therefore, like this can pass through, right? So I mean the combination of this and this can pass through. So therefore, I will have some non-zero values here. And
so in these images, so the first column, so at all the boundary.
Oh, so, okay.
So for example,
wait.
what if
yes.
X is 1, Y is 1?
You mean the boundary? But that
so what about the corner? How to filter the corner, the pixel in the corner, like X equal 1, Y equal 1?
Okay, you guys have several questions. Let's start with sale first. You mean this corner here, let's say?
Yes.
Okay, so let's say if I want to find the filter value at this corner here, so I supposed to look at the neighborhood here to do a dot product of like this thing here, right? So the corner, if my patch is like okay, have some values outside that, let's say, then I will just say continue to take these values here, right? So outside. So if actually on the boundary, then like the only thing I can do is I will just pad 0 like on the boundaries, let's say, or like maybe I can do a refactoring boundary, let's say anything like this guy, I have the last row is like this, then I just reflect that, like copy this like into here. And then maybe after that, I also like on this side, I will just copy this into this guy here. So that would be the boundary problem. So, but
so,
you don't.
So in this example, so all the uniformly 100.
If
the black image.
Oh, you mean for this guy here? So
right.
Here I just considering to filter the center value here.
Okay.
Yeah.
So in the corner, then it'll have some high frequency, like from 0 to 100, right?
Yes, it depends on how you are going to handle the boundary conditions. Yeah, but I don't want to get into the boundary condition because you think of the image is very big, then the boundary condition is that that's
It's
not
that
really
big
that
issue.
important.
I see.
So that's and let me okay. I guess that's two questions quite similar. So what is a high pass and high frequency and low frequency? High freq for low frequency, or like the extreme case of low frequency, or like maybe I do it this way. So what do you mean by like the frequency here is how rapidly your signal is oscillating. So so for example, like if I have a continuous signal here or like continuous case here, so this here will be lower frequency than let's say oscillating like this, right? This would be like high frequency right this way. And I have the lowest frequency will be just like flat basically. So and I can have like even higher frequency, let's say like this. So actually for any signal, for any kind of continuous signal, of course there's some constraint, like basically the energy of the signal is like finite and so on. Actually any signal I can decompose into different frequencies, add them together. If you go for a math class, this is a kind of known as this Fourier analysis and so on, like so, or just a Fourier transform of a signal. Basically, Fourier transform the signal will be like get you the way that the ways to combine like all these like frequency component basically. And but let's not get into Fourier transform here. We'll talk about Fourier transform maybe next time. So, but because every signal I can decompose into like different frequency component. So I can think of like when I do filtering, I'm just think of like I have to filter like what components is allowed to go through. So when I have a low pass filter, it will be like the lower frequencies is going to pass through, but the high frequency is not going to be able to pass through. If I high pass, it's basically the exact opposite. And I kind of like argue here, like for filter like this, like for example, 101 here, 10 - 1 here. This is a high pass filter that like you have like things that is oscillating. You'll be able to pass it through, right? But if it is like something flat, it's not going to pass through that. So therefore, this is a high pass filter. Let's remember like what we have like at the beginning. Okay? So if I have like something like a filter like -1 1, or like I have this -1 0 1 will be something similar, is that like I have something is oscillating. Actually, this won't be a very good example for this case here, but you can imagine like uh, uh, if you're okay, at least okay, it's okay. Let me use this even for this example, it's okay. So if I use this for this example, I will have Oh, actually, this is a bad example in this case. In this case, I will get both of them 0 in this extreme case, but let's say if I have this is not just oscillating 4 6 4 6 and so on, but like maybe I have like 4 4 and then 6 6 and then 4 4 and then 6 6, then you can see that like if I have like filter like this, I will have some high pass component passing through that way. What I get is like the first value will be um will be will be 2. Right, the first value will be 2. Okay, let me put it here. So if I apply to this guy here, like I will have like first value, it will be 2, right? And then second value, let's see, I have here minus 1, 1 here. Okay, let's say this is minus 1, 1. Yeah, it's 2 again. 2 2 and then minus 2 2 minus 2 or something like this. I guess I will get something like this. So anyway, like this signal, like this is again like some kind of like high frequency signal, will be going to pass through that this filter here. But for any just constant signal, it is not able to pass through that. So it is not like an ideal high pass filter, but it's like it definitely will block the low DC, block the constant component there. Yeah. So therefore, like this is like some kind of high pass filter. So when I have low pass, will be like something like doing averaging. So I have like either in this case that that is just saying taking average of like labeling signal. Or like I have also the earlier 1 2 1. It's also like some kind of averaging, right? Maybe I put a 1/4 here, so you can see that it's really averaging. So um I'm not sure like I explained this low pass and high pass like kind of so any uh any further question with the low pass and high pass, low frequency and high frequency, like is that a little bit clearer now? So again, I have signal like you can think of it like yeah. Uh let's see. Let's do one more example. Let's see. Okay, let me okay, let me go back to 1D. So let me go back to 1D first. Maybe it helps. Uh so I need to have a one more page here. Let's see. It's hard to kick this guy. Okay. Let's do some 1D example here. I have, let's say, I have like, again, like I have that filter say that way. So if I have like a signal like 1, yes, I post the lectures. Don't worry about that. Like the video will be available. So so let me do one more example here. Like maybe I just have a constant signal here. So I said like this guy. Actually, you can think of like vertically is like 1 2 1 here. Horizontal is 1 0 minus 1 here. And I just take a row of image. I say like this is like all 1 1 1 1 1, like something like that. So if I apply this filter or apply this filter to this row here, so what do I get here? So I should get all 0, right? Because I take these 3 values here and do a dot product, I get 0 here, right? And then I take this value, I do dot product, get 0 here again, and then get 0 again, 0 again here, right? So the DC component, that's what I mean is that this is a high pass filter, or it is not okay. I guess for one thing, like maybe I didn't emphasize is like don't be for the high pass and low pass is kind of relative. It's not absolute in the sense that it's like not like ideal high pass and ideal low pass. Like if you have if you have taken some class in cell processing, maybe they call it say a high pass filter, maybe in the frequency uh, representation, or like if you have a signal that start with a signal and then you look at the Fourier transform, I mean the frequency representation, like okay, maybe the signal in frequency representation is like this. And now I have the ideal low pass filter, like absolute like this. And then like everything outside this will be completely white out. And or like I can have like a ideal high pass filter that like this, that everything inside this here will be completely white out. So therefore, if I do high pass filter, I get back like a signal like this, let's say in frequency component, frequency representation. So here, like the high pass filter and low pass filter, it's not ideal. Like it probably like I have a high pass filter, something like this, maybe like for this guy. And also like the low pass filter, I probably have something uh, the low pass filter here, I probably have like something like this instead of like really sharp low pass filter. So and and okay. Yes, it's a very good question. Like, if that's a therefore, like, have to be very careful. Like, this is not an ideal high pass filter. It probably like the filter is a more like this instead actually. So for very high frequency that you have here, it turns out just like doesn't go through. So therefore, like what I mean is I have to be careful. Like, yeah, I have like 1010. You give a very good example. Like this, if I apply on this filter here, actually I get like 0000, right? Yeah, that's a very good point. So, but know that like, so therefore, like my filter, if I put it in a frequency representation here, it's actually like for very high frequency, probably is have like zero um response there. But on the other hand, if I consider signal like this, like for example, something will be going to pass through, right? For example, if I have this one, oh, by the way, let's just do this example. Like, what's this value? Like, if I apply this filter to this row here, what's that value? Yes. My question is like, okay, I have this filter here, and I have this signal here. So if I apply this filter on this signal, so what will be the output? Yeah, some of you I think get should be right. So when I mean apply the filter will be like you just take a patch at a time, right? Uh, in this case would be a group at a time. Um, compute the dot product with this guy, right? So therefore I take this first three values here. I compute the dot product with this guy. I will just get one, right? I get one here. Then this another three components I get zero here, and then these three components I got minus one here, and this one I get one here, and so on and so forth. But you see, like I don't get all zeros here. I have something to pass through, right? So therefore, like this is a I say it's a high pass because I at least at absolutely low frequency it didn't pass through, right? But if I have some high frequency components, it's actually a pass through, right? And for example, like as I mentioned, if I have like all one here, actually I would just get zero, 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 something like that, right? Those won't be able to pass through. Um, Now let's look at like this low pass kind of like filter instead. So you have the low pass filter, and let's say if I have what I mean is if I have a high frequency component, let's say I have like uh this example, let's see what is a good example for that. Actually, again, I don't think it's a high. Yeah, you can say it's a band pass. I mean, like it's really a band pass filter, but uh, yeah, you can really, strictly speaking, it's really a band pass filter because it's really like this. Uh, but here I just want to kind of like simplify the um the discussion here. Like I have this part here will be more similar to a high pass because the focus is really like um maybe I don't know, for the very high frequency I said like it won't pass through, but like for the low frequency here like will be won't pass through as well. And that for this one will be like more or less like a low pass like this. So okay, let's get back to like this one. Like if I have this low pass, I want to one here apply on this guy here. So what's the value here? You can do the same thing. Okay, I'll draw it like vertically just for you can write it like horizontally yourself. Yes, it will be all zeros again. Right? I take these three values, do a dot product. If this guy will be just minus one plus two minus one will be zero. Then the second one is like one minus two plus one is again zero. So I will get like all zeros again. So you see like this high frequency component is all able to pass through that, through this filter here. But if I have like low frequency, let's say it's just like a DC, a constant signal, then it's going to pass through that, right? If I have all ones there, then my value will be just like 4, 4, 4, 4, 4, stuff like that. So therefore, I say like, therefore we said like this will be like along this direction is really a low pass, and like along this direction is high pass, right? So okay, hopefully like it clarify things a bit better now. So now if I get back to this filter, so do one final example, I guess uh if I apply this filter to maybe a patch of phi 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 xiu xiu xiu. What do I get? So okay, this is like the last question I got probably. I don't know whether it's last or not. So okay, I'm going to apply on this using this original 2D say filter. Say to this patch here, what do I get? Actually, in this case, I be careful. This will be yeah, okay, it's okay. Like if you think of it extending that, um, maybe I can write more. So yeah, you will get all seals. Like, so if I have this filter, like upon this, like, so you can see like okay, simply I take this patch here and do dot product of this guy will be 3/6, right? And then okay, how do I do that? Like, let's say like 3 times 1, right? Then 3 per se 3 times 2 is 6. And then 0, I don't care about the 0, then this 0, 0, 0. And then like 3 times minus 1 is minus 3, 3 times minus 2 is minus 6. So it'll be 0. And actually, if I have this patch move around to different location, we'll all get zeros as well. But the point here I want to say is like this filter is really doing a low pass in this direction and high pass in this direction, right? And what I have here is like for this signal here, along this direction, it's only low pass, right? Because like for each of the rows here is they are all constant. And just along like for the horizontally like it's getting blocked. So therefore like you don't have any signal can pass through, therefore like you will get all zeros. So in conclusion, so it's a much longer explanation than I thought. Then yeah, much longer explanation than so uh no, I probably my explanation is not great, but let me but or like actually sometimes you just need to wait out. Yeah, no, actually the other way around. Like, you have to wait out yourself to see it. Like typically, like for stuff like that, like, you need to do exercise yourself, like just to play around. Let's say I have this here, and then you really either like write a program or like just like you do self evaluate yourself to see like what's going on. But in summary, like you this thing as we discussed like for the entire class here, it's actually like just decompose into like 1 to 1 in this direction and 1 0 1 minus 1 into this direction. And when you see something oscillating like this, it's actually basically it's a high pass. If you're doing an average, right, more or less like this is like kind of low pass. So therefore, like you are doing a low pass in one direction and high pass in this direction, and it basically will catches vertical edges in this case, because if you think of like vertical edges, what's going on is just you have like high frequency component in horizontal direction, but low frequency direction. How the answers have to be quick, so I'm trying to write it all out and understand. Um, yeah, yeah, but I guess yeah, the answer is like two, but yeah, we will take a very long class, like so. I mean, like I would really, if you don't actually understand what's going on here, like you should spend some time like just try a couple example yourself. Like just go back and write a little bit example and play with it yourself. And actually, you don't need to yeah, you can go with 1D first and uh
Dr. Chang.
yes.
So this the question. It looks like there's a horizontal edge, right? It's between the 0 and 3.
Yes.
So applying this filter still in the horizontal direction is just a high pass filter. So you just make all 0. And along the vertical direction, because it has just edge, it's just smoothed out by this low pass filter. Does it make sense? So it makes all this filter make all the image get 0. Is that correct?
Yes, it does. That's exactly what it's doing here
Uh-huh.
because along this direction is high pathway, so
Uh-huh.
therefore like because this is a horizontal edge, and for the horizontal edge, there's the horizontal component doesn't have like high pass
Uh-huh.
component, so therefore like it just basically get wiped out.
Right.
Yes, and so that's why the whole point is like this only catch a this filter only catch a vertical edges, vertical edge,
Uh-huh.
but not the horizontal edge.
Uh-huh. I see. I see. So this filter
Uh,
doesn't catch this horizontal edge. I see.
yes, this
I
this
see.
will only catch the horizontal. Yeah, that's so that's actually a much longer story than I thought, and so uh, I honestly I'm not sure that's like any reading like for this one like this. I need to look for like readings if you guys are really look for um you let's see. I probably need to, if you really want to look for reading, I probably need to look for that. So, but what I have is a slide here, like that is, I guess it's a pretty, uh, let me look for some kind of like elementary textbook on signal and system. I think it's probably like, but I don't think like you want to go really um deep into whatever. What we're talking here is a maybe I want to make sure like um um uh so yeah, I guess it will be pretty long. I guess I this will be like a little bit on the signal M system, like probably like, but this is like entire course to talk about, like for example, frequency decomposition and so forth and stuff like that. Um, but uh, I guess I in most actual application, like what you what you need to understand is like no matter you have like 1D signal or like higher dimensional signal or like 2D or something like that, you can always like decompose signal into like uh, different frequency components added together as I draw earlier. So then like when you have filter, it's basically um, filter is trying to, for example, if I have low pass filter, I'm going to like have the lower frequency components getting passed. and then the high frequency component not getting passed. And and in 2D, so as what we have here earlier, for some filters, I'm able to decompose into like in different directions. So one direction may be low pass, one direction in the high pass. So in that case, it will be easier to visualize whether you are going to do a detection of a vertical edge or a horizontal edge. By the way, like maybe I just take a poll here. Like, how many of you like have like signal and system that kind of like course before, like just filters? Like, do you have question like, what are you able to follow what we are talking about? Like, if you have taken this course or like, um, uh, so I guess like the problem here is I guess like some of you guys, like many of you guys are from EE background, and maybe some of you like maybe from CS and so on, like have no background. But so how many of you have like kind of like no Fourier transform, like let's say? So I understand that you can be rusty with the um the math and so on. But what I'm saying, like you think of Fourier transform, it's nothing. It's just like you transform from the signal from the spatial domain or like time domain into like a frequency domain will be basically just like decompose into different components here. If you think of like typically like, you have like let's say I have this whatever signal here, and after the frequency of Fourier transform, maybe like you have the representation like this. Uh, you have like signal whatever maybe like this. This is just representing saying that like I have different frequency. I have like so much energy of the signal. For example, like this maybe like some particular frequency here. I have like high energy, and then like even higher frequency, I have no energy, like something like that. So and when we have this filter, like classic filter, it's basically a filter signal like at different frequencies. So for example, you have a low pass filter of this shape. So I'm getting like stuff that outside here is not going to pass that. So you can imagine it's like this signal as multiplying this signal. So and then like what's resulting that will be like something like in this case, more or less something maybe like this here. So and what we talk about like the entire class is basically um, something extending to like 2D because like in 2D will be again like we can decompose into like high pass and low pass like into different direction, and then like what will be I'm actually like if you have taken signal and system also like or like something similar class like you will visualize that this is like a low pass filter, like something like this will be a low pass filter. But on the other hand, like something like that is like will be like some high pass filter. Um so high pass like is yeah, I probably should stop here, but like high pass will be you basically you just think of like what is high pass. Like you think of like putting a oscillating. So if I have left this low pass here, you put in an oscillating signal. I'm trying to do kind of like apply this filter into this oscillating signal, and you'll find that the oscillation will be gone. That will be a low pass. So therefore, this low frequency component will be removed. Sorry, the high frequency component will be removed. And on the other hand, like if you have a low pass filter, the low frequency component will be removed. So yeah, I honestly I think that if you are really we don't understand, it's I may come back like to, if you have any question, or like please put questions in Discord, like we can further discuss that. And maybe some elementary textbook like on signal and system will be helpful, but you probably don't need all of them like to really understand this discussion. Okay, so I guess time's up. I will going to like kind of like maybe just add a few more words like later on. So I will pause here, but if you guys want to raise any other questions, I will answer that. So, but otherwise, I will see you guys on Thursday.
So Dr. Chang, I have a
Yes.
question.
Yes.
So you just showed 3x3 filter today.
Yes.
But is there any other type of filter also possible, like the
Yes.
larger 3x3?
I can definitely make it larger. For example, I can make it like 5x5, right? I can do a filter 5x5, something like 1, 2, 2, 2, 1, or like then 1, 2, 2, 2, 1, and then -0, -0, -1, -1,
So
-2,
there is
-2.
still the low pass filter vertically and high pass filter horizontally, right?
Yes. I can do something similar to this. Uh, okay, so for the present, that's other. I guess regarding the projects and presentation, like first, like the I will post like something more like about that like later on. But I guess the most the first the one is coming up will be your project proposal, and also the presentation abstract. So actually we need to arrange for the presentation as well. Like I'm kind of like anticipating like maybe like 2 weeks after the 2 weeks after your presentation abstract, like we will start like having presentation. So I guess we need to do a lottery like for you guys, like the order of the presentations. And yes, hopefully I answered the question of Heidi. So for for the format of the homework, like I please submit PDF, like that's easier. So you should have just screenshot of like your code running, and then just like also like copy the code into or you may start with a Word file, for example, like if you use Word, and maybe like just screenshot, copy the screenshot into the Word file, and then like copy your code into the Word file as well, then convert to PDF to submit that. So any other questions? So if not, I guess I will stop here now.
Okay. Thank you, Dr. Chang.
Yeah, thank you.